Okay, eighth grade. I have chapter 12.2 notes up right now. That's what you guys are going to work on right now. Those of you that have not been here in a while, we did section 1. So if you have not gotten notes, I would encourage you to find somebody to copy them down from. I do have one packet laying up on the desk. I will keep it up here just in case you need to make a copy. So please make a copy of this because this is the only packet I have left. If you need it, I am not positive if anybody needs any more notes. So we're going to go through 12.2. I do have my book open to 418 if you want to follow along. The first part of the notes is that we get radiation from the sun in about 8 minutes. So it takes about 8 minutes for the sun to go from the sun to Earth at the speed of light. So the best question, if the sun was to blow up, how long would it take us to see it? 8 minutes, probably a little faster than that, but that's a question that gets asked most years. So we also have visible light that comes from the sun. We can see this light. It's converted to thermal heat. We know that because it's warm. The sun feels warm. It's light for us because the earth is lit up. The earth is only lit up because there's the sun. The sun is just a star that happens to be close to us. Also UV light, which is not necessarily good light, which it can't be seen, but it will burn our skin and cause skin cancer. So the ozone layer is a thing in the stratosphere that helps us with that, but it doesn't block out all the UV light, which that is why we still have skin cancer. If we did not have the ozone layer, we'd have a lot more skin cancer in our world. There is something also called IR light, which is infrared light. We can sense IR light as heat. For example, I think there's like detectors that detect for heat, like in a you can use those to see where things are hiding and things like that. But that is also light that comes from the sun. Okay, next we get some energy from the sun, obviously. Some energy is absorbed 20% by the atmosphere. I'm on page 419, so 20% of all energy is absorbed by the atmosphere. UV light is absorbed by oxygen, ozone, and water vapor. IR light is absorbed by water and carbon dioxide. And then visible light can be converted to IR light and then absorbed. So we get all this energy from the sun, keeps us warm, keeps us here. Without our atmosphere, we would not be here. It would be too cold. So some planets don't have the atmosphere that we do, which is kind of a perfect combination. So it's either too hot or too cold. Ours currently is the right amount of carbon dioxide and ozone. Okay. 25% of this is on page 419, 25% of radiation is reflected by the clouds. So if there is no clouds, it's not necessarily reflected. 5% is reflected by surfaces. I guess that would probably depend on what surface. Snow is obviously going to reflect a lot more than pavement. That's why it's warmer in town than it is in the country, because we have a lot more pavement that will keep us warmer. Earth only receives about 50% of incoming rays. Again, if we received all the radiation from the sun, we'd probably be too hot. So this is kind of the perfect combination. Most heat absorbed is radiated back into the atmosphere, explaining why we don't heat up over time, which is a good thing. Okay, we know we are slowly heating up, and that's kind of a cycle that goes on, but a lot of it keeps us balanced. So most heat is radiated back into the atmosphere. Good problem to have. Because we have something called the greenhouse effect, which our gases in our atmosphere act like a greenhouse. So a greenhouse, we keep plants in, the sunlight comes in, and then it converts it to IR, which is infrared, just heat essentially, and we never let it back out. It's like sitting in a car in the summer, which it feels good until it's like absolutely too hot, you can't be in there. And this builds up heat over time. That's what's happening to our atmosphere. We have it right now, and it's not bad, but the more carbon dioxide, water vapor, and methane we put into our atmosphere, the higher the greenhouse effect, the warmer our planet is getting. It is not a debate if our planet is getting warmer. It is. We just don't know, currently necessarily how to stop it without, hurting others. So this is the most people that have ever been on the planet. So we kind of have to figure out this problem. This is probably a cycle that's happened, but we don't necessarily know what's going to happen because we've never had 8 billion people on the planet. Let's see. I think okay. Some planets that are currently too hot because of the greenhouse effect. Venus. Okay. It has too much carbon dioxide in its atmosphere. We don't want to be like that. Nothing can live on Venus. First of all, it's close to the sun, but second, the greenhouse effect is too intense. So, what you are going to do with the greenhouse effect and the ozone, and just thinking about it, you're going to get this packet. So now this packet is going to be handed out for you. It is a large packet. I totally get it. It's not going to be due till Thursday. So right now you have time to work on it. The first part of the page is just you have to define the vocab, which is human population, fossil fuel, concentration, greenhouse gas emission, and glacier. Kind of use your common sense on that. Yes, you can look them up, but I think we can understand what human population is or glacier. Okay, those are all things that are dealing with our atmosphere currently. So part one is human population growth over time. So they're asking you to plot this on the graph. I need you to figure out which one goes in the X and Y axis. Think about it. You want the population to grow over time as you go across on the graph. So they want you to plot the points, and then they want you to connect the points. Also realizing that this goes up to 2010, there are more people on this planet. And I want you to take a look at what point did we get way too many people on the planet? Like what year? And make sure when you're plotting the graph that you are using the entire graph, okay? When you use this much of a graph, you are going to get it wrong. So figure out how you can space them out easily. That might take some time. Use it. Then do the questions. Then part two. Oh my goodness. Part two is looking at global CO2 emissions from fossil fuels. They have put this on the lines for you. You have to graph it. So you should be able to do that, plotting points and doing a line graph again. Answer the questions. I crossed off 3AB and 4AB for you. Do not do those. Part 3 is crossed off completely. Don't do part 3. Part 4, again, this is a pie graph, so use your math skills. Answer the questions, another pie graph, and then a change in glacial mass. So we know glaciers are melting. It is a problem. Sometimes we see this on the news quite frequently. This only again goes up to 2010. We do have some huge concerns about the glaciers melting. That's not a debate. It is happening. So graph that and then answer the questions. Again, you probably won't get this done today. I would say see how you do today. And then we'll go with what we have on Wednesday. So it is not homework. You don't have to finish it on Tuesday night. You'll probably have Wednesday to work. But that's if you're working efficiently. So who's ever in subbing, if they say you're not working very efficiently, then it's going to be due a lot sooner than you guys would like. Also, some people still need to do their vocab and then their web quest as well. So check Power School. Let me know if you have any questions. And everyone has to do one of these. It is not a group effort. So yes, I would assume you could sit by somebody, but if you are not working, you are going to be asked to move. So everyone has to do a packet.